what do we do? How do we apply this equation, summation of force or vector sum of all the forces equal to 0 acting on an object, in a real situation when we're studying the condition of an object, right? That's where free body diagram comes into play. A lot of concepts you learn in this course are gonna be with you for the rest of your, I guess, next 2 years in this in mechanical engineering. Right? Free body diagram. Free body diagram is what connects our knowledge of forces and how can we apply Newton's laws to study an object. Right? If I want to formally define it, we say the best way to apply if we want to apply some of the forces equal to 0 to study an object, we need to think of that object or particle or whatever it is that as an isolated and free form from its surrounding. So if we want to apply this, we need to isolate the object or particle or rigid body from its surrounding, right? How do we do it? We draw a line and isolate that particle that only shows the particle itself, not its surrounding. And then when we draw that line, we look at whatever forces out of those 4 apply to that isolated particle. Right? So a drawing that shows, let's say, the object with all the forces that act on it, where they come, is called free body diagram, or we just pretty much always we just put FBD, free body diagram. How to draw a free body diagram? So to draw that, 3 steps. Imagine the particle to be isolated or cut free from its surrounding. Right? Whatever you want to study, focus on that. Imagine that it is isolated. Cut it free from whatever is attaching it to the surrounding. Draw all the forces that act on the particle and identify those forces, those 4 forces, right? Examples. Right, let's look at an example. Examples. Let me bring 2 simple, straightforward examples that we can actually work with. I need to find it. If I can, I might end up drawing it myself, I believe. Bear with me, don't give up on me yet. I'll tell you when. Let's see. There we go. I think I'm almost there. There we go. It's the first one, not this size. So we have a plate. We have simply you can think about it as a plate suspending by 2 straps, like 2 cables. We want to draw the free body diagram for this. So think about this as a 5 kilogram plate hanging by 2 cables or straps. We want to draw the free body diagram for this. So I'll follow the steps I mentioned. Isolate that. I'm going to draw a line, maybe a better color, and isolate this. Once I isolate that, I look at what I have there. There you go. Let me draw it here. Let's say this is the isolated plate. So what do we have out of those 4 forces? Can you tell me what forces, what should I put on this? What force do I have to take into account out of those 4? Weight, cable, spring, and smooth contact. Out of those 4.
Weight and cable.
Weight and cable, exactly. So I have a weight, and weight is downward, as we say, always. So it's W, and it's 5 kilograms. So W is equal to mg, meaning that is 5 times 9.81. You know the magnitude for that. And cables. All right, let's draw it with a different color. Draw them. One is here, and the other one is there. Remember, cables are always in tension. If you put it the other way around, wouldn't have worked, right? If you have a cable like this, imagine that this is a cable. Oh, better I have it actually here. Imagine this is one of your cables, right? Like this. It's under tension. The weight is pulling it down. The cables are holding it there. Cut it anywhere, the force is the same. So this would be, if I call this, this is point A, I call this T, oh, not this one. I call this TA, right? TA, and this is TB. Tension in cable A, wherever the cable is connected to A, and tension wherever the cable is connected to B. Does that make sense?
Yeah.
All right. Question, if there is, stop me. Look at the another one. Pretty simple, I guess, similar. Let's look at this one. We'll look at more. These are the simple ones. We have a bucket that is kind of held in equilibrium by a cable. You can think about this as a huge crane holding some loading. So a bucket held in position by a cable. If I want to look at the bucket itself, I'm going to isolate that. I'm going to isolate that. And I just focus on this. Now, focusing on this, weight is trying to pull it down. So there goes the weight again. W. We don't know what the value of W is, so we just put it as W. We don't know what's the mass. And again, the force from the cable. This is, it's under tension, so it should be in this way. T, can use a bit of color. T that way. Once you get the free body diagram, all is left is just do vector sum, right? So once you have that, once you have the free body diagram, you can apply or you can apply summation of forces is equal to 0 and find the unknowns that you're looking for. I'll always look at that more detail in an example, a couple of examples. You apply your equation of equilibrium, right? Equilibrium equation of equilibrium that we introduced from here. while ago. There you go. So to see the connection, you know four forces. You draw the free body diagram, isolate, draw those forces on your object, then you apply your equation of equilibrium. That's the process you follow.